Good morning. Hello, everyone. My name is Matt Hansen. As mentioned, I am from Intel in Oregon, and so I've been at Intel a long time. Worked in various hardware and software development over the years. The last 6 years I've been in open source development at Intel, and the last 4.5 or so has been ROS, and now most recently, last couple of years, ROS2. So let me tell you a little bit about us, and kind of I'm going to tell you about our overall development in ROS and what we call our Robot Development Kit, or RDK. So Intel Open Source Robotics, we're all about trying to enable robotics and enable Intel technologies in robotics, making them high performance and using technologies such as Intel RealSense Camera and Movidius, which is our AI acceleration chip, and essentially make things easy for the user to use with ROS2. There's 3 main areas within this dev kit that we're trying to enable. So mapping and planning is one of those. So navigation falls in that category, and I will talk in more detail about navigation. Machine vision, as I mentioned, there's the Intel RealSense Camera, and we have a whole suite of tools and packages that go with that. To enable object analytics and facial recognition, things like that. And then there's intelligent manipulation, so grasping, and we have library packages for that as well. So the first one that I want to show you here is our RealSense camera. And if you look in the top right here, you can see this is basically running SLAM right now using the RealSense camera. You've got a 3D view here in RViz coming up as the robot is moving around in the hallways and creating a map. So our RealSense camera, it gives you 3D point clouds. It can be used for mapping and navigation, obviously here. Object detection and face and gesture detection as well. Another bit of software we have is called Openvino, and this stands for Visual Inference and Neural Network Optimization Toolkit. So what this does is it lets you basically, you train your software model using, TensorFlow or Caffe, and then you can run it through Openvino and basically optimize it for your target hardware, whether that be CPU, GPU, or one of our accelerators like the Movidius VPU or the FPGA. And you get a big performance boost in doing so. So this is showing you some of the different applications that we've enabled with ROS2. There's object detection, facial recognition, age, gender, etc. Object segmentation is this one here in the lower left, where it's recognizing the human on the bicycle as they speed by. And then what we call re-identification, so the person can come into the frame, be identified, leave the frame, come back, and be re-identified as the same person and not a different person. So these are some of the capabilities that are available today with ROS2 with our dev kit. Another one is called object analytics. So this allows you to recognize objects in 3D. And as you can see, it feeds in the RealSense camera on the left side of this diagram here. Shows you start with the RealSense camera, and it takes the raw image and the point cloud. You can optimize it to run with Openvino and optimize it for like Movidius or your GPU, and then you get the high performance object recognition in the top right there. Another capability that we have is grasp detection. So in in figuring out how to grasp things in like a random bin picking type of a way, this basically will come up with a bunch of grasp candidates and pick the best one. And then you can use that with Move It, for example, to then move your robot to the correct pose for the grasping. And this basically works with TensorFlow or Caffe or your standard neural network models. And so the other thing included in the dev kit, which I'll now get into in a lot more detail, is Navigation2. So if you're familiar with the ROS Navigation, what it is it's 2D navigation where you give the robot its current pose and a goal pose, and it will autonomously drive to that location. We started working with ROS2 a couple years back, but it wasn't being used very much yet, and a lot of people were kind of waiting. It was kind of that prisoner's dilemma that was mentioned yesterday. It's like people were interested in ROS2, but they weren't going to move to it until kind of like enough people, other people had already moved to it. So it was kind of one of these self-fulfilling prophecies. So, and one of the big things that was missing was navigation. And so we talked to OSRF and some of the navigation maintainers and said, are you going to do this? And, they didn't really have time. They were like, yeah, we'd like to, but we don't have time right now. So we said, well, would you like to collaborate with us on it? If we picked up the bulk of the work, would you work with us on that? And so we got positive feedback that yes, people wanted us to take the lead on that. And so we went and gathered some input from various community sources and said, if we're going to do this, let's look at it, try to put some fresh eyes on it, and how can we improve it when we move it to ROS2? Because we could do a straight port, but if it's also a good time if there's improvements that are needed, that we could be making those as we go. So we gathered some input, and I'll talk more in detail about what we've done with Navigation2 to improve it over ROS. But before I get to that, I wanted to give one other slide here on the dev kit. So it includes all the things that I've already previously told you about, right? The RealSense and Openvino, object analytics, et cetera, and navigation, of course. And we have one company in China that's already created a product with this. So this is the Yunji Deli platform, and it's running using our dev kit. As you can see, it's basically like a, you can think of it kind of like a bus boy in a restaurant. It's running trays out to the restaurant floor for the servers to then take food and serve it to the people, and then you can put the dirty trays on it and it'll take them back to the kitchen for you. So that's one application already running with our dev kit. Okay. So now I'll do a little more deep dive into Navigation2, which is probably what most of you wanted to hear. So, so as I mentioned, we asked the community for input, like what do you like about ROS navigation? What do you not like? What would you like to see improved, et cetera? And we got quite a bit of responses and excitement, from people about this. And a few different themes kind of emerged from, the input that we got. So I've tried to list out the main, things here. One of them was customizable logic. If you know the ROS navigation, you know that it's been forked a lot of times. A lot of people basically take it and they want to make some changes. They don't like quite the way it works, so they fork it. They kind of create their own fork, and then they work in that. And then a lot of times that never gets upstream back to the main line, and this just kind of continues to happen over time. So we wanted to try to make it so it was customizable without having to fork it, and therefore, hopefully, kind of prevent this, this sprawl, I'll say, of forks. And then modularity. People wanted to be able to more easily replace planners and the control algorithms and be able to basically replace them with like Python versions, et cetera. Like in the original nav stack, it's all C++, so you can write C++ plugins to change out your algorithms, but we had some people saying, well, I'd like to be able to use Python. So that was part of the extensibility as well. And then there were some additional things that we as software engineers wanted to try to improve with the nav stack, that maybe, weren't really community input, but, these were kind of internal goals, I'll say, that we took. So reliability, we wanted to make the system reliable so that it was consistently behaving the same way. Quality, we wanted to make sure that, everything was very well tested. And maintainability, so, we wanted to make sure that over the long term it was easy to meet all of these goals, right, and didn't become some big spider web that was too difficult to maintain. So that's what the Navigation2 project has been, and we've been working on this we started this in mid-2018, and did our first release, Crystal release last year, and then we did the dashing release mid this year, like July-ish, and then now we're about to do our eloquent release. So to meet those goals that I talked about, there was several changes we made to Navigation2 versus Navigation1. I'll get into more on that, but for customizability, we changed out move base for behavior tree based approach. For extensibility and modularity, we changed the planners and the recovery behaviors to basically be ROS2 actions with plugins. And for reliability, we changed everything to Lifecycle Nodes. And we added system tests, and we added continuous integration for the quality and maintainability. So if you're familiar with ROS Navigation, you've probably seen this picture before on the wiki. You can go to that link there if you want to go find it. But it's kind of the classic picture of ROS1 navigation. And so what I'll do is I'll go through this kind of block by block and explain to you what we've done. So AMCL and map server, they were pretty much straight ported from ROS1. We did some refactoring along the way and some code cleanup to try to make it, easier to use and maintain. But for the most part, they're still their interfaces didn't change, and so they're from the outside perspective, they're pretty unchanged. Move base is no longer there in Navigation2. So I get people sometimes asking me, well, I went to look at Navigation2, but I didn't see move base anywhere, and I tell them, well, that's intentional. Move base is gone. So what we've done is we've replaced it with behavior tree based navigation called BT Navigator, and I'll go into more detail on that as well. Recovery behaviors, we also pulled these out, and these are now actions that can be called from the behavior tree, as well as both the global planner and the local planner. Similarly, those are now behind ROS2 action interface, and they're all callable from the behavior tree. I'll show you a picture in just a minute that kind of shows what the new stack looks like. And then the global and local cost maps, they're still there. There are still plugins within those planners. And we've added new nodes that are basically the planner server and controller server, and those are the action servers for the global and local planner. So this is what it looks like at a high level. You have, instead of move base, as I mentioned, you now have the BT Navigator, which basically has a ROS interface that accepts a navigate to pose action. And once you call that, it will then call compute path to pose, which is calls the planner server, which contains your global planner called NavFN planner. If you're familiar with ROS1, it's basically ported from ROS1, and then the follow path action is for the controller server, and the implementation of that is the DWB planner. And if you don't know what that is, in ROS1 there was the DWA planner, the dynamic window approach, and then later David Liu created a newer version of that he called the DWB planner. So we ported his DWB planner, which is kind of the new improved DWA, into Navigation2. And then you still have map server and AMCL, as I mentioned, and recovery behaviors are now callable from the behavior tree as well. And this shows you an example where you would call a spin action to the recovery server to cause the robot to spin. So I've mentioned behavior trees a few times. I know I've had some conversations with people just, over lunch or coffee or breakfast or whatever about behavior trees. So I know that there's some people in the room that know what they are and are quite familiar with them, so that's great. For those of you that maybe aren't as familiar with them, this is kind of the super high level overview of what they are. It's basically a decision tree with different types of nodes that control your flow and what actions take place. So this example shows, you have the root of the behavior tree at the top, and then a sequence node means that it will do the thing on the right branch. Well, I guess for the audience, the left branch and then the right branch. So basically it will come through the sequence node and it will hit the retry node, which basically will continuously keep retrying until it gets success from its child node, the fallback. And then the fallback it's similar to the sequence, but it's kind of like an if then else. So if you get to this node and is it clear, if the answer is yes, then it will go back up. If the answer is no, then it will say read the documentation. And then it will get back to the retry node and tell you to do it again until is it clear returns true. So it's telling you keep reading the documentation until it's clear, and then at that point you can build awesome robot behaviors. So why did we use behavior trees? As I mentioned before, it enables customizable logic and behavior flows without rebuilding the code. All of this is basically something that can be done in XML, and I'll show an example of that as well. And it also enables extensibility, so you could, like right now we're using the behavior tree for navigation, but you could use behavior trees for adding more than just navigation. So you want it to navigate point A to point B, and then you want it to film something, and then you want it to grasp something. These are all extensions that you can do with a behavior tree, and you don't have to really rebuild the code in order to do it. So here's an example. As I was mentioning, it's all definable in XML. You need to define the nodes themselves, which there's a library we're using called Behavior Tree CPP that defines most of the control nodes, and then the action nodes are custom that you have to create. So we create a custom compute path action client. Basically, it calls the ROS2 action that, we have the action server, which I mentioned on a previous slide, which is the compute path action, right? Which calls into the global planner. So the global planner gets called and returns a path, and then that path basically gets followed by the follow path node. And then if you fail to navigate, then you can try this recovery flow over here where there's clearing global cost maps and spinning, et cetera. And that's all behind the recovery server that I mentioned before. So this is a kind of a simplified tree here where you're just seeing compute path, follow path. If either one of those fails, then go do a bunch of recoveries, but it can quickly, you can customize this and create your own recovery flows and all of that. So it gets more complex, but this was, to kind of give you the high level view of things. So one of the goals I mentioned was reliability, right? Basically being able to show that able to do the same behavior every time. So one of the ways that we enabled that was through Lifecycle Nodes. So ROS2 has this concept of Lifecycle Nodes. It's basically a built-in state machine in the lowest level of the code that you can see the state machine diagram here. When you first create the node, it starts out in an unconfigured state, and it just stays in that state until you walk it through the state diagram here. So, and you do that through ROS service calls. So you call a service to configure it, and it goes from unconfigured to inactive, and then you call another service to activate it, and it goes from inactive to active. And you can control through your callbacks what actions are taking place at each given time. So maybe you're using the unconfigure to inactive state transition to go read all your parameters. That's what we're doing, for example. So we go read all our parameters and everything in that state transition, and then going from inactive to active basically starts your publisher flows and starts your callbacks and all of that, where you're really doing real work when you're in the active state. And so overall, with this flow, we're able to get much more reliable startup with ROS2. Without this, in ROS2, when we were launching all the nodes at once, everything was coming up simultaneously, and it was creating a ton of discovery traffic happening at the same time, and it was kind of causing race conditions that we were having a hard time, figuring out and debugging and all of that. Once we were able to control the BringUp flow a lot more, we were able to weed out a lot of those issues and become a lot more reliable. In order to control the flow for the whole system, we needed kind of a helper node, for lack of better words. So we called it Lifecycle Manager, and basically it's in charge of that bring up and shut down. So we basically it's a server for the Lifecycle Manager Manage Nodes service here, as you can see, and you can tell it what nodes you want it to manage and what state transitions to do, and it will basically take care of those at the macro level for you. And then if you want it to basically just bring everything up in sequence, then you can give it a parameter from a parameter file that says, auto start of true, and here's a list of nodes, and it will walk them all through the state transitions in sequence for you. So it's very convenient. So we launched this automatically as part of our launch files. Another thing that we have is a plug-in interface. So I mentioned this before for all of our planners and the recovery behaviors. So similar to in ROS1 navigation, you had the nav core interface. We have this nav2 core interface. It's similar concept, slightly different API, but allows you to basically write another C++ plugin for a different planner if you don't want the navfn planner, and you can load it in through the planner server with just changes to the parameter file. Just give it the name of your new planner plugin. And as I mentioned before, the planner servers, and the controller server, all of these, since they're callable through ROS2 actions, you can actually replace those with a Python implementation if you want. That was why we did that way. So you have flexibility both ways. You can either replace the server, or you can just replace the plugin if you want. Another new package we've added for navigation for convenience of launching everything is the Navigation2 BringUp. You guys probably, everybody's at some point probably done the Turtlebot tutorials and used Turtlebot BringUp. This is a similar thing that wasn't there for Navigation1, but so we added this, and basically it's got the launch files that you need. Here's an example of how you would bring up the whole system for simulation, and with auto start set to true, so that all the nodes will, so the Lifecycle Manager will walk them all through the state machine. If you want to use it, you can go to our repo and go to the Nav2 BringUp README, and you know, pretty easy to use. So another thing, as I mentioned before, for quality and maintainability, we wanted to make it so it was easy to test really quickly. And in Navigation 1, everything was tested manually. So we added Nav2 system tests, which basically runs in a Docker container and launches everything with a Turtlebot 3 in a gazebo, and moves a robot from a known location to another known location, makes sure that everything works well. And it's very fast to do this, and we're able to basically integrate that into our CI and use it with on every pull request, so you can prove that you're at least not having regressions and that your robot still moves. It's basically a smoke test. And with this test, we're also able to run it hundreds of times, and this was very helpful when we were debugging some of these race conditions, because they'd only happen maybe 5% of the time or something like that. You could run until until you hit it, and then you could debug it, and you could run like 100 times in an hour. And with this, we were able to drive our pass rate, get rid of race conditions, and drive our pass rate from about 85% on dashing to like 95+% now on Eloquent. So running a little long, I'll try to finish up here quickly. We're about to release our ROS2 Eloquent release this week. We're planning for our Foxy release now. We have, that's in 6 months. So we have kind of a feature list that we're prioritizing. It's in our repo. If you want to go take a look and see what we're looking at doing for Foxy, please do that. And you can give us input or feedback if there's things you want us to do that we haven't done yet. So here's a link to our repo. Please come try it, test it out for yourself. If you want to get more involved, we run a weekly navigation working group, and you can sign up through that link right there. If you need to, you can contact me through Discourse or just find me here and get my info. I'm happy to do that, and hope you get involved in the working group. And last but not least, I want to recognize the team. So I'm here as a representative. I've been leading the project, but as you can see, it's not a one-man show here. We had 6 full-time people working on this, plus a couple interns, plus we had major contributions from Steve, who is at Samsung Corporation. So the whole team has done a great job on this. They all deserve credit. So thank you very much.